Hello, my name is JaeHyeok Choi from Seoul National University, and my title is Finite N Black Hole Cohomologies. We will consider supercharged cohomology problem in N equal 4 super-Yang-Mills theory with gauge group SUN as a pathway to understanding BPS black hole microstates via ADS-CFT correspondence. This is based on the Hodge theorem in field space. In other words, BPS operators are in one-to-one correspondence with Q cohomology class. There are well-known cohomologies that are called gravitons because they correspond to single particle states in the gravity side. For example, these are the gravitons, which are in the stress tensor multiplet. And partition function for gravitons at n equals infinity gives an upper bound on the degeneracy of multi-graviton states because they trace relations only decrease the number of states, and the upper bound is given by e to the n to the 5/3, which is much smaller than e to the n squared. And this means that for large n, cohomology is typically non-graviton, whose degeneracy is e to the n squared, and we want to find them. Since it is extremely computationally expensive to scan all possible free BPS operators to find non-graviton cohomologies at one loop, as in this paper, we first computed graviton index, which counts gravitons only, to identify the charges that non-gravitons are guaranteed to exist. We resorted to brute force computer-based counting. However, there are two important details. First, all the fields can be diagonalized when counting multigravitons. Second, trace relations among the multigravitons can be systematically dealt with using graviton basis, and in simple cases, it is possible to compute the graviton index exactly. For example, one can exactly compute the index of gravitons, which contains these letters only in SU2 theory, and this sector is called BMN sector, which is a consistent truncation of the cohomology at one loop. Therefore, we can compute the superconformal index of this sector by not including other fields by hand, and the result is given by this formula here. And all of these BMN sector non-graviton cohomologies were found in this paper. Non-graviton index for SU3 theory is presented in this way, where we factored out these factors here, and we computed this z core up to the t to the 54th order, and this factor in the numerator is from the super descendants, and this factor in the denominator is from the conjectured graviton hair, and the result is given by this table. Here F means fermion and B is boson. There are singlet towers, and there are these towers also. Here the numbers represent Dynkin labels of SU3 R symmetry, and we explicitly constructed this singlet threshold cohomology in our paper. And here U and V are addressing complicated operators here, and U and V are given by these, and these are gravitons, and the energy of our cohomology is 21/2. Thank you for listening.